First, let's make sure my equations of the quadratic form. We have three terms, they're equal to 0, the last term's a constant, and if you look at the exponents, the first exponent is twice as much as the second exponent. So this is definitely of the quadratic form. So I would like to rewrite this as 5 times x to the 1/3 squared plus 11 times x to the 1/3 plus 2 equals 0. Notice that these two inside the parentheses should always be the same, and that is what I'm going to make my u equal to. It's always the middle term's variable part. So whatever your middle term is, that's 11x to the 1/3, that's your u, the variable part. Notice I didn't take the 11, I just took the variable part. So when I translate it from x's into u's, that gets me 5u squared plus 11 times u plus 2 equals 0. So this is now a quadratic equation, and it's not that bad to solve. So I'm going to go ahead and use my guess and check over here to the side. I'm going to try 5u and 1u and 1 and 2. Multiply, I'm getting 10u and 1u, and if I make them both positive, that will get me 11. So these factors into 5u plus 1 and u plus 2. Set each of those equal to 0. So I'm getting u is equal to negative 1/5 and u is equal to negative 2. Don't be too hasty. Don't think you're done here, because you're not. You've only solved for u, but the question didn't even have u's. You're the one that brought u into the problem. You need to take it out and put it back into x's. So I can replace u with x to the 1/3 and now I'm going to solve each of these equations. So in order to solve an x to the 1/3, I'm going to raise it to the 3/1. Because the 1 is odd, I don't have a plus or minus on this problem on either of these equations, so I'm going to raise it to 3/1, which is really just 3, isn't it? So now I have x is equal to negative 1 cubed, which is negative 1, 5 cubed, which is 125. On the right hand side I have x is equal to negative 2 cubed is negative 8. So these are my two potential answers. I say potential because on step 5 it says I have to check my solutions. It's mandatory if the original equation includes rational exponents, and they do. Because there's a fraction in the exponent, I have to check my work here. I must. This is not something I can just skip over. So I am going to first check x equals negative 1/125. So I have 5 times negative 1/125 to the 2/3 minus plus 11 times negative 1/125 to the 1/3 plus 2 is supposedly equal to 0. Okay, so I need to work out the negative 1/125 to the 2/3, which is the cube root of negative 1 squared over the cube root of 125 squared, which is, let's see, negative 1. The cube root of negative 1 is negative 1, and negative 1 squared is positive 1. The cube root of 125 is 5, and 5 squared is 25. So this is 5 times 1/25 plus 11 times, now I've got to do 1/125, that's negative, to the 1/3, which is the cube root of negative 1 over the cube root of 125, which is negative 1/5. I put the question mark on top because I'm not actually sure if they're equal. When I multiply here, I have 5 over 25 plus negative 11 over 5 plus 2 over 1 is supposedly equal to 0. I need to get a common denominator of, let's see, 25. So I can multiply this one by 5. I can multiply this one by 25. 5 over 25 minus 55 over 25 plus 50 over 25. So that gets me, truly does get me 0 over 25. And 0 over 25 is 0, so the first one checks out. So x equals negative 1 over 125 truly is an answer. I'm going to have to use some space over on the other side. Hopefully this one won't be quite as bad because it's not a fraction. So now we're going to check x equals negative 8. So we have negative 8. We have 5 times negative 8 to the 2/3 plus 11 times negative 8 to the 1/3 plus 2 is supposedly equal to 0. So I've got to figure out what negative 8 to the 2/3 is, and also negative 8 to the 1/3. Negative 8 to the 2/3 is the cube root of negative 8 squared. The cube root of negative 8 is negative 2. Negative 2 squared is 4. Negative 8 to the 1/3 is just the cube root of negative 8, which is negative 2. So we have 5 times negative 8 to the 2/3, which we said was 4, plus 11 times negative 8 to the 1/3, which we said was negative 2, plus 2 is supposedly equal to 0. So that's 20 minus 22 plus 2. Look at that. It does equal 0. So both of our answers check out. On our next problem, notice we have 3 terms. It does equal 0. The last term is a constant, and if you look at the exponents, this 2 is twice as much as the 1. So this does qualify as a quadratic form. This one's actually even set up as the quadratic form already. So we're just going to let u equal the middle term's variable part, which is x plus 3. So I'm going to replace this as u squared plus 7 times, replace x plus 3 with u, minus 18 equals 0. Again, this is our translate. So we're going to translate it into u's. Why? Because it's easier to solve as a quadratic here. This is something that is not so bad. So I have u plus 9, u minus 2, that factors. And then we have set each of those factors equal to 0. I'm getting u equals negative 9 and u equals positive 2. Don't think for a second that you're done though, because we had a problem that started with x's, so we need to answer in x's. So I'm going to use my u translate, and every time I see a u, I'm going to plug in an x plus 3. So x plus 3 equals negative 9. And for the other equation, I have x plus 3 equals positive 2. Now I'm going to solve in terms of x's, so I'm going to subtract 3 from both sides and get x is equal to negative 12. So my two solutions are negative 1 and negative 12. Now I don't have to check those because it didn't have a rational or a fraction in the exponent. All right, looking at our last problem, we have 3 terms. It does equal 0. The last term's a constant, so this does qualify as of the quadratic form. Notice that the first term's exponent is double of the middle term's exponent, so this does qualify. So I can rewrite this as 2x to the negative 1 squared, because negative 1 times 2 is negative 2, minus 3 times x to the negative 1 plus 1 equals 0. I'm going to let u be equal to the middle term's variable part, x to the negative 1. That's the same thing that should show up in both parentheses. When I translate this x equation into u's, I get 2 times u squared minus 3 times u plus 1 equals 0. So I've translated it from the red x equation into u's. So now I'm going to solve in u's, because this is now just a quadratic equation. I'm going to now try to factor it. The only factors of 2 are 1 and 2. The only factors of 1 are 1 and 1, so I sure hope this is the only choice that we have. So I get 1u and 2u. Can I use 1 and 2 to get to a negative 3? Sure I can, with both negatives. Two negatives multiply to a positive but add to a negative, so that works. We have 2u minus 1 and u minus 1. Set each of those factors equal to 0. So I solve and I get u equals 1/2 and u equals 1. Okay, am I done? No, I'm not done, and I'm not done because I've solved for u, I haven't solved for x. So I need to use my little translate up here in the corner and replace, every time I see a u, I'm going to replace it with x to the negative 1. And then I can solve the rest of my equation. X to the negative 1 equals 1/2. X to the negative 1 equals 1. So there's something that you probably need to remember. Any number to the negative 1 is 1 over that number. This is from previous sections that we've taught you in the past. So if I need to get rid of an exponent of negative 1, I want that exponent of negative 1 to become a positive 1. So I'm going to raise it to the negative 1, because negative 1 times negative 1 is positive 1, and that will get me just x on the left-hand side. Now, what is 1/2 to the negative 1? Well, to the negative 1 exponent just means flip or reciprocate the base. So if the base is 1 over 2, then I reciprocate it and it becomes 2 over 1. So therefore, that's really just 2. All right, x to the negative 1 multiplies out to positive 1. 1 to the negative 1, that's 1 over the base 1. But 1 over 1, no one writes that. We just write 1. So my solutions here are 1 and 2 in either order. And that concludes this lesson.